Our solar system is a fascinating place full of wonder and mystery. Each planet has its own unique characteristics and quirks that make it special. From the scorching surface of Mercury to the stormy clouds of Jupiter, every planet tells a different story. Among its many wonders is the ice giant Uranus, a planet that stands out for a truly bizarre reason. It's tilted on its side. This unusual tilt gives Uranus a unique set of seasons and a very different way of experiencing day and night compared to other planets. Imagine a world where the sun barely rises above the horizon for decades, then moves into a period of constant daylight. This is the reality on Uranus, where one pole can bask in continuous sunlight for 42 years, while the other is plunged into darkness. That's Uranus, a planet that challenges our understanding of how planets form and evolve. Scientists believe that a massive collision with an Earth-sized object billions of years ago could have knocked Uranus onto its side, creating its extreme axial tilt. Uranus is a giant ball of gas and ice, the seventh planet from the Sun. Its atmosphere is composed mainly of hydrogen, helium, and methane, which gives it that distinctive blue-green color. It's 4 times the diameter of Earth and has a faint ring system. These rings are made up of dark particles, making them difficult to see with the naked eye. But what truly sets Uranus apart is its extreme axial tilt, a characteristic that makes it unique among the planets in our solar system. This tilt affects everything from its weather patterns to its magnetic field, making Uranus a subject of great interest and study for astronomers and scientists alike. Every planet in our solar system spins on an axis, an imaginary line through the planet's center. This axis is crucial for the planet's rotation, which in turn affects many aspects of the planet's environment and behavior. The way a planet spins can influence everything from its weather patterns to the length of its days and nights. This spin is what gives us day and night. As the Earth rotates, different parts of the planet are exposed to the sun's light, creating the cycle of day and night that we experience every 24 hours. This rotation is also responsible for the beautiful transitions of sunrise and sunset. The axial tilt, or obliquity, is the angle between a planet's rotational axis and its orbital axis, the plane in which it orbits the sun. This tilt is not just a minor detail, it plays a significant role in the climate and seasonal changes of a planet. The degree of this tilt can vary greatly from one planet to another, leading to vastly different environmental conditions. Earth, for example, has an axial tilt of about 23.5 degrees, which is what causes our seasons. As Earth orbits the sun, this tilt means that different parts of the planet receive varying amounts of sunlight throughout the year, leading to the progression of seasons from winter to spring, summer, and autumn. Uranus, however, has an axial tilt of about 98 degrees. This is an extreme tilt compared to other planets in our solar system. Such a dramatic tilt means that Uranus experiences very unusual seasonal changes, with each pole getting around 42 years of continuous sunlight followed by 42 years of darkness. This means that Uranus is essentially spinning on its side, with its rotational axis almost parallel to its orbital plane. This unique orientation affects not only its seasons but also its magnetic field and atmospheric dynamics, making Uranus one of the most intriguing planets to study. This extreme tilt is what gives Uranus its unique characteristic of being a sideways planet. The planet's unusual orientation has puzzled scientists for years, and continues to be a subject of research, as it challenges our understanding of planetary formation and dynamics. The mysteries of Uranus remind us of the incredible diversity and complexity of our solar system. The question of why Uranus is tilted so dramatically is one that has puzzled astronomers for centuries. The most widely accepted theory is that Uranus experienced a cataclysmic collision with a massive object, possibly a planet-sized body, early in its history. This catastrophic impact, according to this theory, would have been powerful enough to knock Uranus off its original axis and leave it spinning in its current unusual orientation. While there's no definitive proof, the evidence supporting a massive collision is compelling. Section 4. Extreme Seasons and Chaotic Weather. Uranus's extreme tilt has a profound impact on its seasons and weather patterns. Because of its sideways orientation, Uranus experiences seasons that are unlike anything seen on Earth. Imagine a world where each pole experiences decades of continuous sunlight, followed by decades of complete darkness. This extreme variation in solar energy creates unusual atmospheric circulation patterns. While Uranus doesn't have the same distinct seasons as Earth, it does experience extreme variations in temperature and wind speeds as it orbits the Sun. Section 5. Unlocking Uranus's Secrets, the Voyager Legacy. Our understanding of Uranus has been greatly enhanced by data from spacecraft, particularly NASA's Voyager 2, which made a historic flyby of the planet in 1986. This mission was a monumental achievement in space exploration, providing humanity with unprecedented insights into one of the solar system's most mysterious planets. Before Voyager 2, Uranus was largely an enigma, a distant blue-green dot in the sky. The spacecraft's journey to Uranus took nearly a decade, traveling over 1.8 billion miles to reach its destination. Voyager 2 provided us with our first close-up images of Uranus, its rings, and its moons. These images revealed a complex and dynamic system, with rings that were much darker and narrower than those of Saturn, and moons that showed signs of geological activity. The spacecraft's cameras captured stunning details of Uranus's 5 largest moons: Miranda, Ariel, Umbriel, Titania, and Oberon, each with its own unique characteristics and mysteries. The spacecraft's instruments also collected valuable data on Uranus's atmosphere, magnetic field, and internal structure. This data revealed that Uranus has a peculiar magnetic field that is tilted dramatically relative to its rotational axis and offset from the planet's center. The atmosphere was found to be composed primarily of hydrogen and helium, with trace amounts of methane giving the planet its distinctive blue color. The internal structure of Uranus suggested a composition of water, ammonia, and other ices, making it an ice giant rather than a gas giant like Jupiter and Saturn. Voyager 2's flyby of Uranus was a pivotal moment in our exploration of the outer solar system. It marked the first time a spacecraft had visited Uranus, and the wealth of information gathered during this encounter has been invaluable to scientists. The mission expanded our knowledge of the planet's unique characteristics and laid the groundwork for future exploration. The data and images it sent back to Earth revolutionized our understanding of this enigmatic ice giant. The mission's success demonstrated the incredible potential of robotic space exploration and inspired a new generation of scientists and engineers to continue the quest to unlock the secrets of our solar system. Voyager 2's legacy lives on, reminding us of the boundless possibilities that await us in the vast expanse of space. Section 6. The Future of Uranus. Exploration. While Voyager 2's flyby of Uranus provided a wealth of information, there's still much we don't know about this enigmatic world. Scientists are eager to send a dedicated mission to Uranus to study its atmosphere, magnetosphere, and interior in greater detail. A dedicated mission to Uranus would allow us to answer some of the most pressing questions about this icy giant, such as the composition of its atmosphere, the structure of its interior, and the nature of its magnetic field. Section 7. A distant world connected to our own. Uranus, despite its distance and strangeness, holds clues to the formation and evolution of our solar system. Studying Uranus can help us understand the processes that led to the diverse array of planets and moons we see today. By unraveling the mysteries of this tipped-over world, we gain a deeper understanding of our own place in the cosmos. Uranus is a reminder that our solar system is a place of endless wonder and discovery, a cosmic tapestry woven with beauty, strangeness, and the fundamental laws of physics.